Using significant figures in math. Now, depending on what kind of mathematical function you are doing, the solution, or your answers, will need to be reported to the correct number of significant figures, and this is determined by which math process you use. In the blue corner, we have multiplication and division. And in this case, your solution is going to have the same number of significant figures as your, and I put this in quote, parent, for example, the numbers in your initial problem, with the fewest significant figures. So if we take a look here, this number 4.85 has one significant figure, two significant figures, and three significant figures. It has 3 sig figs. But now, if we look at this number, 1.4, it has one significant figure, two significant figures. Is there any way we can predict how many significant figures my answer is going to have? I hope that you say my answer is going to have 2 sig figs when everything is said and done. At this point, I put this in my calculator, 4.85 times 1.4, and I get a number 6.79. 6.79. Now I need to include a unit, and in this case it's meters, and hopefully you can recognize because it's meters times meters, it's meters squared. But am I done yet? No, I'm getting close though. I need to apply the correct number of significant figures. And so, according to my significant figure rules, this number is going to be significant, and this number is going to be significant, and 9 here is not going to be significant, but it's important because before it goes away, it has an opportunity to influence the number before it, which in this case is a 7, and your answer is 6.8 meters squared, and that is correct according to significant figures. If, on the other hand, I am doing addition and subtraction, the rules change a little bit. The solution will have the same number of places after the decimal, and I denote this with the term pad, as your parent, in this case the numbers that you're adding together, with the fewest places after the decimal. And in math lingo, this is known as the precision of the number. And so if we take a look right here, this number has a number in the tenths, and the 100ths, and the 1,000ths, and the 10,000ths, and the 100,000ths, and the millionths. And so it has 1, 2, 3, 4, 5, 6. 6 places after the decimal. But if you look at this number, it has a number in the tenths, number in the hundredths, number in the thousandths, and a number in the 10,000ths. And this number has 1, 2, 3, 4 places after decimal. So what's my answer going to have? I hope you recognize that my answer is going to have 4 places after the decimal. Now when I type this number into my calculator, I get 0.000198. And in this case, it's feet. And I'm really close to being done, but now I need to respond to the appropriate, in this case, significant figure or place. And I hope that we can understand that this number is going to be reported because it's in the correct place. This number, and then this number will be reported, but the 9 will not. But it is still important because before it goes, it is going to have an opportunity to influence the number in front of it. 0.0002 feet, and that has the appropriate places after the decimal. Now there's another way that I can think about this, and basically, do you remember the way in which you were taught how to add and subtract decimals? And I think you were taught this more vertical system, where basically the key was we wanted to line up the decimal so that the decimal was always in line. Alright, and so when I do addition this style, you will see that I have numbers here to add, and here to add, and here to add, and then here to add, which is the same, exactly the same process that I did here. But I think that you will see that, look at this column, both numbers contribute to that addition, and this column, both numbers contribute to this addition. Same thing here, and same thing here. But right here, I have some difficulty because there's no number there in which to contribute in this column, and so therefore it cannot be significant in my answer. And so, if this column is the first one that I'm missing, when I respond to with my answer, I'm going to respond to the first, second, third, fourth place after the decimal. The 9 has an opportunity to round the 1, so 2 feet. Of course, every rule has one exception, and this is the one exception to these rules. When the mathematics that you end up doing involves either a conversion factor or a ratio that is set by definition. In other words, scientists agree to the 20th decimal place or more. These numbers will not contribute to significant figures of the answer. Now, let me give you an example. 1 foot equals 12 inches. And you know what? When they invented a foot, basically they got together and said, can we divide this up? Somebody said, sure, let's make it 12 increments. Let's call them inches. And so that was set by definition. This is set by definition. Okay, but in reality, this is kind of the lazy way of writing. In reality, because it's set by definition, I could say 1.0000000000000 feet equals 12.000000000 inches. Now, in reality, you don't want me to force you to write this way, but would you agree that there is an insane number of sig figs here? And if that is the case, the significant figure rules both state that they are looking for numbers with the fewest number of significant figures. So therefore, these numbers never contribute to the sig fig of the answer. Good luck.